This is the video for part 5, fraction division, concepts, and visual representations. Make sure you have the guided notes for part 5 in front of you before you continue with the video. Okay, what does it mean to divide? It's easier to understand the concept of division if we think about it in terms of dividing a larger number by a smaller number or vice versa. So we're going to start by talking about division of a larger number by a smaller number. With whole numbers, for example, the division problem 6 divided by 3 equals 2, we think conceptually of this as asking how many times can 3 go into 6? How many times can the smaller number go into the larger number? And we can see that 3 can go into 6 2 times. We can see it on the number line here as well. There's 3, it can go into 6 1 time, 2 times. Okay, the concept is similar with fractions. Got an example problem here. 2/3 divided by 1/3 equals 2. We're asking how many times can 1/3 go into 2/3? How many times can a smaller number go into a larger number? We can see how many times can 1/3 go into 2/3? Well, there's 2/3. 1/3 can go into it 1 time, 2 times, for a quotient of 2. Now, when we're talking about dividing a smaller number by a larger number, the question is a little bit different. So now we're conceptually thinking how much, in this case, 3 divided by 6, how much of 6 can go into 3? So now we're dividing the smaller number by the larger number. We're asking how much of 6 can go into 3? Okay, if we've got 6, we want to know how much can go into 3. Well, there's 3. Half of 6 can go into 3. And when we do that computation, 3 divided by 6, we would get 0.5, 5/10, or 1/2. The concept is similar when we talk about fractions. When we divide a smaller number, 1/3, by a larger number, 2/3, we're asking how much of 2/3 can go into 1/3. So we've got 2/3, we want to know how much of 2/3 can go into 1/3. Well, 1/3 is there. Half of 2/3 can go into 1/3. So you've got guided notes prompts here, 2, and from the previous slide, 1. Take a moment now to go to your guided notes and fill in that missing information. You can pause and come back when you're ready. Okay, multiplication and division are inverse operations. We know this is true with whole numbers. It's also true with fractions. So for example, we look at the problem 1/2 times 5/6 equals 5/12. We're looking for 1/2 of 5/6. The inverse problem, 5/12 divided by 5/6 equals 1/2. Also true. Okay, we look at the same thing here with area model representations. 1/2 times 5/6 is 5/12. 5/12 divided by 5/6 equals 1/2. So those things are still true. So fraction division isn't the mystery that sometimes students think of it as. It's a natural extension of what students understand about whole number division. Now let's look at the direction of effects. So for whole number division, we know that the quotient of whole number division is going to be less than the dividend. So let's look at examples. 12 divided by 3 equals 4. Our quotient 4 is less than the dividend, or the starting number. Here's another example. 10 divided by 2 equals 5. Our quotient 5 is less than the dividend, our starting number. This direction of effects holds true for fraction division with improper fractions. or numbers that are greater than 1. The quotient of improper fractions will be less than the dividend. So here's an example. We've got an improper fraction, 16/4, divided by an improper fraction, 8/4, for a quotient of 2. That quotient, 2, is less than the dividend, or the starting number, 16/4, which would be equivalent to 4. So the direction of effects for whole number division is the same as the direction of effects for fraction division with improper fractions. However, as we saw with multiplication, the direction of effects for proper fractions flips. So the quotient of 2 proper fractions, fractions less than 1, will be greater than the dividend. Let's look at this example. So we've got 2/5 divided by 1/5 for a quotient of 2. This quotient 2 is greater than the dividend, the number we started with. Again, this can be confusing when students first work with fraction division with proper fractions because the quotient is larger than the terms in the problem. And that is the opposite of what students have learned to expect from whole number division. So we have to help them understand conceptually why they get a quotient that is larger than the dividend when they divide proper fractions. I'm going to take a second to look at division procedures, because this is another thing that causes students some difficulty. So with fraction multiplication, we know that we just multiply right across numerators and denominators. 1/2 times 5/6. We multiply 1 times 5, the numerators, for 5, and we multiply 2 times 6, the denominators, for 12. Procedurally, students typically learn that pretty quickly and don't have a lot of trouble with it. With fraction division, we are essentially operating in the same way. We divide across numerators and we divide across denominators. So for example, 5/12 divided by 5/6, 5 divided by 5 equals 1, 12 divided by 6 equals 2, that's 1/2. But we don't teach students to operate this way. We teach students to invert and multiply. So when given a fraction division problem, same problem, 5/12 divided by 5/6, we teach students to invert the second fraction and multiply. So then they would multiply 5/12 by 6/5, get a product of 30/60, which simplifies to 1/2. Notice this is the same answer. When we invert and multiply, we are making a shortcut to do the same work you see here, dividing across numerators and denominators. Why do we do this? Because it's not always neat to divide across numerators and denominators. Here's another example. 5/12 divided by 6/7. If we just divide right across numerators and denominators here, we don't get a whole number or an easy answer here. 5 divided by 6 is 83/100. 12 divided by 6 is 1.71 or 1 71/100. If we simplify that, we get another decimal, 49/100. If we invert and multiply, however, we can get a fractional answer that makes sense and that students can use. So 5/12 divided by 6/7, we teach students to invert the second fraction and multiply. They get 35/72. And then this fractional answer students can work with, or if you simplified, again, you'd get the same decimal answer because you are doing essentially the same thing but using a shortcut when you invert and multiply. Here's an illustration of what's happening when you invert and multiply. So when you invert and multiply, you just invert the second fraction and then multiply numerators and denominators. If you were to do this problem longhand, you would first divide across numerators and denominators. And here you're getting two fractional answers. Then you want to eliminate the fraction in the numerator by dividing the numerator and denominator both by 4, the denominator, which would give us 12/4 over 20/7, which could simplify to 3 in the numerator. And then we've got to simplify this fraction in the denominator. So we multiply both the numerator and the denominator by 7, the denominator here, which would give us 21/20, which is the same answer we get when we invert and multiply. This is a very complex procedure and takes a long time, and there's a lot of opportunities for students to make mistakes here. So this is why we don't teach this. We teach invert and multiply, but it's important to understand that invert and multiply is giving us the same answer as just dividing straight across numerators and denominators would. This is the invert and multiply procedure, which is complicated enough on its own. And this is a flow chart for the procedure, so you can see why students make mistakes when they learn procedurally how to divide fractions. But invert and multiply is the less complicated of procedural options. So some common errors that students make when they divide fractions involve inverting both fractions or inverting the wrong fraction. So let's look at some examples of that. In this first example, we can see the problem was 5/6 divided by 1/2. A common error would be for students to invert the first fraction instead of the second fraction, or the second term, and end up with a quotient 6/10. So that's inverting the wrong fraction. In this next example, we see the problem 5/6 divided by 1/2. We see the student inverted both fractions. So they're multiplying 6/5 by 2/1 to get a product of 2 2/5. And then finally, we see another common error, 5/6 divided by 1/2. We see the student just multiplied here rather than divided. So that's another common error. Now we're going to look at a common error in context and make the connection to magnitude understanding. So again, if you understand the direction of effects of fraction division and you have a sense of fraction magnitude, you can see why these computation errors don't make sense when we put them in context. So here's a common error, 2/3 divided by 1/9. The student inverted the first fraction instead of the second one, so they got a quotient of 3/18, which simplifies to 1/6. The quotient of two proper fractions should be greater than the dividend. Here our quotient 1/6 is smaller than the dividend. So we can see, just thinking about the direction of effects, that this quotient is not reasonable. It doesn't make sense. Now let's look in context. Sammy is using her phone. It has 2/3 of its battery life left, and it drains another 1/9 every hour. How many hours will her battery last? So she's got 2/3 battery life left. She's going to lose another 1/9 of life every hour. How many hours will the battery last? 1/6 of an hour. Does that make sense? It doesn't make sense at all. So in this case, we're dividing a bigger number, 2/3, by a smaller number, 1/9. We're asking how many 1/9 can go into 2/3 to find out how many hours of battery life we have left. So how many 9s can go into 2/3? Start with 2/3, and then to find out how many 9s we can put in 2/3, we have to divide the number line out into 9ths. And we want to know how many 9ths can go into 2/3. So 1, 2, 3, 4, 5, 6. 6 1/9ths go into 2/3. So we've got 6 hours of battery life left. And again, thinking about the direction of effects, when we divide two proper fractions, our quotient should be greater than our dividend. And now we've got a quotient that makes sense. This is greater than our dividend. Okay, now we've got another problem to look at in context. So here's a common error, 1/4 divided by 1/12. The student inverted both fractions by mistake and got an answer of 48. 48 over 1 simplifies to 48. The quotient of two proper fractions should be greater than the dividend. In this case, this is definitely greater than the dividend. 48 is definitely greater than 1/4. So this obeys the direction of effects, but we're going to see when we look in context that this answer just doesn't make sense. So let's look at our story problem. A turtle can walk 1/12 kilometer in an hour. The turtle is 1/4 kilometers away from a pond. How long will it take the turtle to reach the pond? So if the turtle can walk 1/12 kilometer in an hour, that means he can walk a kilometer in 12 hours. So it doesn't make sense that it would take 48 hours for him to walk a 1/4 mile to the pond. So I can see already that quotient doesn't make any sense. Here we're dividing a bigger number, 1/4 kilometer, by a smaller number, 1/12 kilometer. So what we're asking is how many 1/12ths can go into 1/4? If we look at a visual representation, we want to see how many 12ths can go into 1/4. So we mark off fourths and we find 1/4. Now we want to know how many 12ths can go into 1/4. So next we would divide the number line into 12ths and count off how many 12ths can go into that 1/4. 1, 2, 3. So 3 12ths can go into 1/4, and 3 is a much more reasonable quotient. 1/12 divided by 1/4 divided by 1/12 equals 3. It would take the turtle 3 hours to reach the pond. That's a quarter kilometer away when the turtle's walking 1/12 kilometers in an hour. Okay, so quick review of direction of effects. With whole numbers and with improper fractions, the quotient is smaller than the dividend. But with proper fractions, the quotient is greater than the dividend. So let's estimate and apply the direction of effects like we did with multiplication. We're going to look at proper fraction division. So here are two proper fractions. Our rule tells us, our direction of effects rule tells us the quotient will be greater than the dividend. So we're going to use benchmarks again to work this out. 11/24, again that's about 1/2, divided by 24/50, about 1/2, equals 23/100, about 1/4. So our quotient, 1/4, should be greater than the dividend, 1/2. This is not the case. 1/4 is less than 1/2. So based on the direction of effects rule, this is not a reasonable answer. You're going to try this out. Go to number 5 on your guided notes sheet, and you're going to assess whether this quotient is a reasonable answer for this proper fraction division problem using the rule. The quotient should be greater than the dividend. Is that true here? Is the answer reasonable? Go ahead, try that out, and then come back to check your answer. No, 2/9 is not a reasonable answer here. The dividend is more than 1/2. 6/10 is greater than 1/2. Our quotient, 2/9 is less than 1/2. This is a smaller number. The quotient is a smaller number than the dividend. So this violates the direction of effects rule. This is not a reasonable answer. Okay, let's look at the rule for improper fractions. Fractions greater than 1. The quotient of two improper fractions should be less than the dividend. So let's think this through. Is this quotient less than the dividend? This quotient, again, is about 1/4. Our dividend here is, let's see, about 2. So is 1/4 less than 2? Yes, it is. So this could be a reasonable answer. You try this next one out. You're going to use the improper fraction direction of effects rule to determine whether this quotient is reasonable. Go to number 6 on your guided notes, think this through, write your answer, and then come back to check. Okay, 110 over 20, 110 twentieths, not a reasonable answer. This is improper fraction division, which means our quotient should be smaller than the dividend. In this case, our dividend is a little bit more than 1, and our quotient is a little bit more than 5. This is a larger number. The quotient is larger than the dividend. This violates the rule, so this is not a reasonable answer. Okay, now we're going to move on to modeling fraction division using visual representations. As we saw when we learned to model fraction multiplication, creating visual representations helps make the process visible and helps build conceptual understanding. When we divide a larger number by a smaller number, we're asking how many times can the divisor go into the dividend? How many times can 1/10 go into 4/5? How many times can the smaller number go into a larger number? So we can see here's 4/5. How many times can 1/10 go in there? 1, 2, 3, 4, 5, 6, 7, 8 times. When we divide a smaller number by a larger number, we're asking how much of the divisor can go into the dividend. We're dividing 1/10 by 4/5, a smaller number, by a larger number. We want to know how much of 4/5 can go into 1/10. Got 1/10. How much of 4/5 can go in there? 1/8. Got 8 parts, 1 shaded. So you're going to use the same process we used with multiplication to learn to make visual representations to model fraction division. You're going to watch the videos and follow along and do work on your guided notes sheet. You're going to work along on numbers 7, 8, 9, 10, 11, and 12. Again, you'll just watch the model video, follow along, and make representations along with videos for the first and the second guided practice. And then you're going to try out number 10 and 11 on your own before you watch the videos for feedback. And then if you want more practice, you'll watch extra practice videos number 1 and 2. So you're going to stop this video here and watch this series of visual representation videos before you come back for part 6.